Hello, guys. Okay, now we're going to do, this is two sections from Unit 6 that we did not cover, that I pushed to later. This is simplifying radicals with square roots and cube roots. Okay, so we're going to start off. The nth root of a number, a, can be written as the radical expression in radical a. So let's name these things. The n, which is normally not written when it's a square root, is called the index. Okay. The symbol, the square root symbol, is called the radical. It's to erase. And that's the square root symbol. Okay. And then a, which underneath the radical, is called the radicand. Okay. If there is no index, what I just said, n is assumed, it is assumed that n equals 2. Okay. When it's a cubed root, you'll see a 3 written right there, or anything above a 2. If a radical has more than one root, the radical sign indicates only the principal or positive root. So we don't have to worry about right now writing the plus or minus. We just treat it as being positive. All right, we're going to list the first 12 perfect squares. Just so that they're fresh in your mind, you do get to use a calculator, so that's helpful. But having this is going to be helpful when it is not a perfect square that's underneath there, which we'll get to. So they are 1, comma 4, comma 9, comma 16, comma 25, comma 36, because 6 times 6 is 36, and so on. Then 49, 64, 81, 100, 121, 144, and actually if you go, the next one is 169, which is sometimes used, and that's 13, the square root of 13. And then 14 is not as used as often, but I want to get to 15 because that one is used quite often. Second square root, and I'm drawing a blank on what 14 is for some reason. Oh my goodness, clear, I can't type. 196, there we go. I knew that one. 196 is the square root of 14. And then 225 is the square root of 15. So actually having all of those is helpful. So I went further than 12. All right, so let's look at a couple of problems. Now, number 2, first and foremost, the first thing I'm going to do is I'm going to always take what it is and punch it in the calculator. So I'm going to have second square root 484. Okay, and I'm going to get enter, and that's a whole number. If it gets to being a decimal, that's when we're going to do our next step we're going to learn. So this equals 22. Easy peasy. Okay, now when I'm looking at number 6, I treat this as being -5 times the square root of 121. So therefore, I'm going to then have -5 times 11, which gives me a final answer of -55. Okay. When we have it as a fraction, we separate that and we treat it as -9, the square root of -9 over the square root of 100. That looks like a 4. Looks like a 9. So then the square root of 9 is 3. The square root of 100 is 10. So my answer is 3/10. All right, moving right along. Okay, now we're going to talk about when it's a non-perfect square root. Okay, you find the largest perfect square that the radicand is divisible by. So largest perfect square divisible by, break down the radical using this number. So we're going to break it down Then we take the square root. So let's do that part first with number 10. So I'm going to break it down. I got to think of perfect squares. 2 is not a perfect square. 3 is not. 4 is a perfect square. And then that's going to be 4 times 6. So this is going to break down to the square root of 4 times the square root of 6. Okay. And 6 can't be broken down any further, so we know that's the smallest it can be. So then I'm going to take the square root of the perfect square. So we're going to then, it's going to take it out of the radical. So I'm going to end up with 2 radical 6. And then you leave the leftover under the radical symbol. Notice the 6 is still under the radical symbol. There's my answer. It can't simplify any further. All right, let's do a couple of more of those. So number 12. Okay, so I'm going to think, well, 72, if you divide it by 2, 72 divided by 2 is going to be 36. 36 is a perfect square. I don't think it can be any bigger. 49 doesn't go into it. 64 is not going to. So it's got to be 36 and 2. So therefore, this is going to break down to the square root of 36 times the square root of 2. Notice I always write the perfect square first because you want that to end up outside of the radical. So now the square root of 36 is 6. Can't break this down any further. So therefore I bring it down and it's going to be 6 square root of 2. Oh, that just happens to be the reverse there. It's not done by design. It's just coincidence. Okay. Moving right along. Okay, and again, if you've got questions, stop and ask or rewind and listen. Okay, let's look at 245 real quick. Okay, now 343. Okay, so if I'm looking at 343, I have no earthly idea. So what I'm going to do is I'm going to think about, okay, I want a perfect square. So I'm going to just start dividing. Okay, well, I'm going to see if, okay, I'm going to just start dividing. I know it can't be divisible by 25. It's not going to be divisible by 4. So I'm just doing 343 divided by 36 is the next highest one. 36, enter. Nope. 343 divided by 9. Nope. 343. I did 36, so let me try 49. Enter. Oh, I got a whole number. It's just guess and check at that point because you're checking to see if it's divisible by a perfect square. Okay, so this is going to break down into the square root of 49 times the square root of 7. So then this is going to become 7 radical 7 as the final answer. Okay, now we're going to move on to cubed roots. Okay, so we're going to start by listing, because you can use this list of the 10 perfect cubes. You normally don't go above that, especially at this point. Okay, so we have 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. Okay, so now we're going to do some cubed roots. Remember, cubed roots mean it's going to be a number multiplied by itself 3 times. So if I'm looking at this, I can break up the 8 to be 2 times 2 times 2. That's why it's a cubed root. So when I take the cubed root, which we can do in the calculator, okay, the way I'm going to do this is I want it to do a math function. There's math. Okay, and if you scroll down and you look right there, it's got a cubed root. Okay, so let me write down these steps as we go. Okay, so in the calculator, calc steps. Okay, step 1 is you hit the math button. Step 2 is 4 or scroll to 4 and press enter. So I'm just going to hit the 4 because that's what I like to do. Hit the 4 and you notice it already puts me in the calculator for me. Okay. And I want 8 and then I arrow out of it and I press enter. And the glare is blocking my answer. So it tells me that my answer is 2. But that's only going to work if it's an actual cubed root. Okay, so let's do another one. Let's look at 26 because you're like, wait a minute, it's a negative underneath there. It can't do that. But this is a cubed root. This is different. Okay, so we're going to do math 4 negative. Remember, it's the negative button with the parentheses, negative or 343, arrow out to be outside the radical, and we press enter. And notice it's a -7. And that's because it's doing -7 times -7 times -7. So my answer here is -7. Okay, moving right along. We're going to talk about, let's see, step 3. Type in number. Step 4. Scroll out of radical. Step 5. Press enter. Okay. Right up here. Okay, somewhere else because I wanted to have those calculator steps. Okay, so if I'm looking at the square root, the cubed root of 40, first thing I'm going to do is type it in and see, okay, math 4, 40, arrow out, enter. That ain't going to work. It's a big long decimal. Okay, so that means I've got to now look at the perfect skews. So we use the same method, okay? We're going to look for perfect cubes to break down the radical. So I'm going to look up here and I'm going to look and see, okay, 27 ain't going to work inside 40, but 8 will. So this can break down to the cubed root of 8. And yes, when you write the cubed root, you have to write the 3 times the cubed root of 5. Well, the cubed root of 8 equals 2. So this is going to be 2 cubed root of 5 as my final answer. Okay. And now let's look at one more. 36. Yes, I'm moving down. Okay, that's a huge number. So that's going to make me think it's going to need to be something up above. If it ends in 5, with only one other that ends in 5. Well, I have got 1,000, that would be 0, 125. So I'm going to try 125 and just see if 875 is divisible by 125, because I really have no idea. So I'm going to do 875 divided by 125. Does it give me a whole number? Oh, yes. So that's perfect. Okay. So I want the negative on the 125 because that's a cubed root. I want as much to come out of the radical as I can get. So we're going to do cubed root of -125 times the cubed root of the +7. Because remember, it's 1 positive, 1 negative to be able to get to a -875. And then this is going to be no longer, once I take the cubed root, it's outside. Okay, so we're going to have -5 cubed root of 7. There's my answer. Okay. Your assignment is to do the odds. The evens are extra credit. Have a great day. Bye. If you have questions, make sure that you rewind, pause and rewind, and make sure that you ask. Bye.